Hello, this is a video on manometers and barometers. Marom- Manometers and barometers are devices that measure gas pressures, and it's all based on what is called compressibility or incompressibility. Compressibility is a substance that if you change the pressure, its volume is going to change. Incompressibility or incompressible, okay, or compressible, incompressible, those are other words used. If it's incompressible, if you apply a pressure, the volume does not change. And usually, what happens, in general, liquids and solids, the condensed phase, that's what they're called, are incompressible, and whereas gases are compressible. And the reason why, over here, and the reason why this is the case, it's due to how far away the particles or the base units are from each other. And as you know, gases, the base particles are very far away from each other. Okay, in liquids and solids, they're not. In pressure, this means kind of get them close together, increasing pressure. Now, specifically, how does barometers and manometers measure gas pressures? By this time, you should have you can obtain a blind copy of this handout. Um, the principle is the fact that since liquids are incompressible, if you apply a pressure to one side of a liquid column, the other side of the liquid column will move, so the whole column will move until the other side has the same pressure. So each ends will have the same pressure. Okay. Um, a barometer is a device that measures barometric pressure, and barometric pressure is atmospheric pressure, the pressure in the room. That's what barometric pressure is. Okay. Manometers are different than barometers because manometers measure the pressure of two different gases compared to each other. And they do it using a liquid level. And the most easiest one to think about is what they call the U-tube manometers. And that's example is right here. And it's exactly what it is. It's a hollow tube with a liquid in between, and in this case, each liquid level is experiencing atmospheric pressure. And since atmospheric pressure is equal on both sides, so the assumption is this gas here is at the same atmospheric pressure as this gas here. That's why the two liquid levels are the same. The way I remember manometers and barometers is using the seesaw. As you know, a seesaw is that thing with the that you and somebody else sit and you go up and down. Well, if you both have the same mass, and mass is a way of saying, in this case, pressure. If you have the same mass, you're going to be straight across, and that's in that. So if you think of this this guy right here, the gas pressure here is the same size person as this pressured gas over here. Of course, the water level is going to be the same because they're the same pressure, so they're exerting the same push on each side, so the levels are the same. Now, how is a barometer different? Well, in a barometer, you don't have one of the sides. That what happens is the liquid level, which this liquid here goes all the way up to here, and there's a gas contained in here. So you can think of a barometer as a U-tube manometer, where one side of the barometer, which is over here, is the atmospheric pressure pushing down. So therefore, this side of the liquid is pushing up on this gas. And this gas is contained in here. So it just moves, compresses, or expands due to the outside gas, which is the atmospheric pressure, and that's why it reads the barometer, the outside pressure, the atmospheric pressure, which we call barometric pressure. Okay, so that's how barometers work. So barometer is kind of like a YouTube manometer where there's only one side. That's why you're not going to look at the difference in the heights of the two liquids. Over here, that would be analogous to this is one side and that's another side. So it's just the recorded distance from that level of the liquid up to this level of the liquid. Okay, that's how you record the barometric pressure. What you can do with a YouTube manometer, you can stick a gas on one side and have it open to atmospheric pressure, and then you can look at the differences between these two sides to figure out what the pressure in the gas in the container is. And we do this on the other page. So this is what these pages look like. So here's my gas. It's in a balloon. This side's open to the atmosphere. So if the once they equate, if the liquid level on both sides of the YouTube manometer is equal to each other, that's telling you that this pressure and that pressure is the same. In essence, it's a seesaw. This guy weighs exactly this guy. So they're equal to each other. Now, conceptually, without doing math, you can figure out the relative pressures between the two, the gas in the container and the atmospheric pressure. Because if you look, just like a seesaw, if this is the liquid level on this side and this is the liquid level on that side, this guy's fatter, heavier. So therefore, it's gonna push down, and therefore this guy must be lighter. So the atmospheric pressure must be greater than the gas pressure. By how much? Well, by the difference in this level and that level. Delta H is an indication of difference in height. Okay, and that's why if you look at a lot of the pressure terms in your gas pressure handout, they're all lengths of liquids, like millimeters of mercury or feet of water. That's what it's measuring, is this distance here. Okay, so that's one condition. The other condition, of course, is the opposite. This is lower than that, so this guy is fatter, has a higher pressure than that guy. By how much? By that distance. Okay. So now what I did is I did some math. You can look at the math, but it applies. What I just talked about applies. Okay. So what I'm doing here is I'm just instituting a mathematical relationship: the minus the delta H, the plus delta H. And you don't have to do. Most of the times people don't care. I give you the answers to the next pages, like problems. These are problems on the next page. So here's A. You have a gas contained in here. You want to know what the gas pressure is, and you have atmospheric pressure here. And what you see is that this level is lower than that level, which means the fact that this pressure is greater than that pressure. By how much? Well, the difference in the two heights. And if the atmospheric pressure is 756 millimeters of mercury, and the difference in height is 42 millimeters of mercury, and the pressure of the gas is greater than the atmospheric pressure, you need to add them. And when you add them, you get 798 millimeters of mercury. So that's the pressure of this gas. So example A. Example B, what we have here is, if you look, this pressure, atmospheric pressure, is higher than gas pressure. By how much? Well, the difference, which is 15 millimeters of mercury. So the gas pressure is going to be less. So you can subtract the numbers. So the gas pressure should be 630 millimeters, which, again, it is. And then the last one, or you can do this all day long. Now we have the gas pressure. We know what it is. We're looking for atmospheric, and we look, and the gas pressure is greater than the atmospheric pressure. By how much? Well, 48 millimeters of mercury, the difference. So if you subtract these two numbers, what you get is atmospheric pressure, which is, I believe, what is it, 794? If I did the math right, yep, 794 millimeters of mercury. So that's a way in which you can figure out one gas pressure compared to another gas pressure using a U2 manometer. And that's usually the types of calculations that people ask you for. Now, of course, these 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 manometers and barometers are still being used in industry for measuring gas pressure. They're digital ones now, but a lot of times the manometer is still used. And on the first planes, just a little side note, on the first planes, they actually had little manometers on the wings of the plane to record the pressures. And they were called, since they're so small, they were called piezometers. And that determined how the plane flew. So that was just an example of how manometers and barometers work. Okay, hope this helps.